Well, you know where we are now. We're on day 3. What's inside? Hi, and welcome to another episode. What we've got here is the PiHut Advent calendar of Let It Glow, and it's day 3. So let's pull it out and see what we've got. Right, so let's move the box to one side. Open the little plastic bag. I have to say, not so fond of little plastic bags all the time. Don't really need them, do we? We've got boxes. I realise it makes it easier for packing in the long run, but if you had lots of little trays already set up on your workstation and you could dump them in at the warehouse. Whinge, 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 but it's Christmas, so let's see if we can stop whinging about it. I'll stop talking about the plastic bags now though. Right, so we've got some cables. We have a green thing. Oh, it's the caps. We've got a green cap and we've got a red cap. Just in case you're a bit colorblind, there's a green one and there's a red one. And we have 2 micro switches. Quite big, chunky things. Click, click, click. Right, so let's go across to the website and see what we've got to do. As you can see, I haven't connected up the Pico yet because it tells you that in the instructions, doesn't it? We know that. So let's move the mouse pointer. Right, box contents, we have a green 12mm square tactile button, a red 12mm square tactile button, and 5 male-to-male jumper wires. There we go. Right. Let's scroll down a bit more. Today's activities are we're going to learn how to use the buttons in a circuit to trigger things in our code, such as printing text, lighting our LED, and counting numbers. Okay. We'll be introducing some new skills in the functions, and that will come in handy as we progress through the calendar. Good. Again, as those that you've played around last year will be familiar with the buttons, blah, blah, blah. That's fine. We're not so lucky at the moment. We didn't get one last year, we got a different thing, but that's fine. I understand why that's in. I'm not complaining, not complaining. I mean, I was talking to a friend about this, and basically it'd be a nice idea if, I don't know, you had last year's and you had this year's, and you know you've done all last year's projects and you've done all this year's projects, and at the end of it there's a bonus project of where you can mix things together. But you know, double your money's worth and sort of encourage you to keep getting them year after year. Anyway, how does the button work? We all know what a button is. Most of us use them every day. However, some might be wondering what makes them work and what's going on underneath in a colourful colour. Colourful cover even. Anyway, buttons simply give us an easy way to make or break a circuit. That's fair enough. The difference between microcontrollers is that the circuit can be used to send a signal, an input, whenever the button is pushed, which can then tell our code to do something. So we could do it so that we push the button and things. The next electrical signal of 3.3 volts. I play around in the GPO. Let's get on with building it. We need the breadboards. So let's get them into place. Trying to spin around because of the cable. Can we do that? Yes, we can do that. There we go. Alright, to fit the buttons, you should have the LED from yesterday's box still in place. If not, head back to day 2 and rebuild the circuit. I've left it as is because prior experience with the one from last year, not PiHut one, a different one. So I'm going to just put these, let's follow through on what it says, right? Fit the buttons. I'm going to put them over here somewhere on the top board. So we need the pins or the legs to them, and they should be that way, you know, not not that way around with the shiny legs, that way they should be this way, top to bottom. And we need them in different places. It feels like it's going to loose or pops out, or the black base of the button isn't touching the board. You've not been firm enough when putting them in. Okay. The buttons straddle the central break of the breadboard, which stops two sets of legs touching. Okay. Let's get on with doing that then. So we need they seem to be plugged into all the top lot of legs on D1. Is that in? There we go, pushed all the way down. I don't know what colour top they want on them, does it really matter? Anyway, and then the one next to that. There we go. Just like that. So I've put the top right leg of that one in D1, and that fits you for the rest of it. There's no stuff, and it's squashed or pushed all the way down. I'm just going to make the button on the right a red one and the one on the left. Go. If there's an international standard I don't know about, tell me. I don't think it really matters though. I've got go and stop. Don't be surprised. Different standards in different places around the world. But anyway, we are first going to create a 3.3 volt power rail. That's in bold, so that must be important. Using one of the red lanes, which we can then tap into. There's only 3.3 volt pin on the Pico, so this allows us to make multiple connections to it. Connect a jumper wire from the 3.3V3 out pin, which is a physical pin 36. Let's have a look where that is. Then fit it on the other end to the top rail. Okay, so I'm just going, doesn't seem to have told you which colours to use, but since it's talking about connecting up red and everything, I'm peeling off the red wire, the red cable I should say, because it has got plugs on the end. But yeah, it's calling that as pin. So the wire, it is called wire. So jumper wire. Even out. So pin 36, which happens to be not lined up very well. Right. How do we know this is pin 36? We've got, I know I'm pointing down here, I'll need to zoom in again, I think. Let's do this so we can see what's happening. Whoa, a bit too much. Right. The dots it's got across here is 1, 2, 3, 4, 5 across and 1 down. So 1. So it's the 5th hole on row I on the second board, the bottom board. Push that in. There we go. I'm going to take this all the way up to the top board and the rail across the top and the top right one. So there we go. That should be, when it's all connected up, passing power, then it should be doing. Okay. Pin rail connect to the blah blah blah, connect to the top left leg of each button. Okay, so we need some of the cables. Again, it's not mentioned colours. So in our case, what I'm going to do is going to take the grey and the white one. Really doesn't matter because they are just wires, but so I'm going to do it. We want it from the third one. we go. Make sure everything's pushed in and connected, and then we want it to be done so that it's the third one across still. Top row, so row A, yeah, row A, column 3. I'm using this white one, just using the same spots they've got in their diagram. Oh, come on, this one's been a bit funny going in. There we go. Whoop. Careful, don't be too hasty with it because the pins on the end are a bit bendy. And then we need this one, and this is row 1, column 8, because it counts 1, 2, 3, 4, 5 that way, just in case someone's jumped in on the third day. Right, we've got that going. We've still got our cables from yesterday, the resistor and the LED. Right, finally we need to connect the other side of our buttons to the GPIO pins. Connect the left button, the lower right leg, to GPIO 3, which is physical pin 5. Okay. So this is row J, column 6. That's getting connected to, let's say, pin 5 on that one. That should be easy to count because doing it so on the bottom board, column A, pin 5. This one's been awkward as well. There we go. And take the last wire, and we want for the button on the right hand side now, we're going for column J, row 1, and that's going to the one next door to the last one we just put in, so that's on the bottom breadboard, column A, number 4, column 4. There we go. A few tips and pointers it's saying to us now. If the jumper wires feel like they don't want to go in, just give them a little twist. Sometimes they just get a bit caught on something, and rotate them slightly helps that. Okay, that little tip would have been nice before we started doing it. It just would have been. Once you start running the code, you'll find that the button is constantly detected as being pressed. It's likely that you've hooked a wire up wrong, so we'll look out for that. If you find the button just won't stay put and keeps popping out, try moving the jumper wire to a different hole in the same lane. Okay, right. Activity, basic button usage. Playing around with the MicroPython, that's the Pico first, then move it so slightly more to advanced objects. We're going to reuse some of these things we've used yesterday, most of the while loop. Loops are commonly used for buttons and inputs as they can be used to continually check the status of the input, see if it's changed or not. Right. Inside our while loop, we'll be using something new, an if statement, to determine what happens when a button is pressed. Okay, if statements, you've probably used them in Microsoft Excel, and it gives you a load of expressions on what happens there, but basically it talks about pulling down the code, or pull downs. Our code also uses pull downs. You can see this at the end of each of the button setup line. pin.pull_down. So why do we add this? When we use a button, we're sending 3.3 volts to the GPIO pin is set to high. However, we need to make sure the pin is low in the first place, or our code might not be able to take the change stuff. So in a way, I think it's like we're initializing it, which means we're setting up the idea. Like I showed you yesterday, of where they should have put some code in of where it set it to 0, so that the LED was already off when the code started, so we knew where we were going from, instead of maybe the LED was already on and you tell it to turn on, and how do you know it's turned on if it's already on? So it seems to be that's what this means. And then we're on about the code. The code starts with while true loop. The while loop contains an if statement that looks for a high, a signal 1 on GPI 2. If the button is pressed and the signal is sent to the pin, our code will print red button pressed. Now this would have been nice if it had told us which button was which. It didn't tell us anyway, did it? Just double checking, it didn't tell us which button was the which one. It didn't tell us if it was green on the left or red on the... It should have told us that. It just talks about putting buttons on the left or on the right and things. Alright, so we'll find out the hard way now which one's the red button. Alright, so first things first, let's get this plugged in. Oh, I'm an old man. Where's my cable? There we go. Plugging it in. So now it's live, there's 3.3 volts going through it. We need to get Thonny up and working, don't we? And it said yesterday, quick way to do that is just to press the stop button. And there we go, it's ready, soft reboot. Right, let's cut and paste this code in here. Let's paste. Alright. We press run. Red button. Right, the green button's currently not doing anything. It happens to be that the button on the right hand side is red. What a guess. Right. Activity number 2. Just like when we added additional LEDs to our code yesterday's box, we'll be adding your second green button to the script and altering the code to do something different depending on which button is pressed. The first part is adding the pin setup line. Just duplicate the line and call it something different. We went with the obvious green button. Change the GPIO number to 3 as well, as our green button is connected to that pin. Right. Then all we need to do is add a second. All we need to do then is add a second line if statement to tell our program what to do if different inputs are pressed. Okay, so let's get rid of all this. As always, I highly recommend that you type this out, not just cutting and pasting. I'm just trying to get this through quickly. Alright, so we copy the code, paste it, press play. So we've got a red button and we should have a green button now. There we go. So I guessed though that the green was on the left and the red was on the right. I should have told us at the beginning, but let's get on to activity number 3. Oh, we finally get to play around with the LEDs. Before we go any further with inputs, let's bring our LED back to the party and control it with our inputs. We'll make our green button turn the LED on and the red one turn it off. To do this, we first need to add back in the LED pin setup code from yesterday's box. You'll see this under the button setup lines in the example below. And basically there's the if statement. Simply, if it's there, do it. Right, so we'll copy the code. Now we shall press play. We shall run it. So press the green button and that should turn on the red LED. If we've got too much light in here, let's turn the light down a little bit. You should see it fading now. Right, so press the green button. Yay, the red light came on. Press the red button. It stops. So we're turning it on and we're turning it off, and we've got text for us to be able to see that as well as. That's pretty cool. So now we're actually doing something that takes the physical aspect from the outside world, gets processed in the Pico, and then gets sent back out again, or turning a light bulb on and off. We're halfway there for making a smart device. Actually, we're not, because this doesn't have Wi-Fi on it or anything, does it? But no, that's not being funny. Back in the olden days of my GCSE electronics, it was simply an on-off switch. But now there's some programming involved. Right. 4. Toggling LEDs with buttons. Using our buttons to turn the LED on and off is handy, but in reality, most devices in our home use a single button to toggle them on and off. What if there's a better way? The toggle function. There is! The toggle function does exactly what you'd expect. It toggles the state of the pin between high and low, meaning you can use a single button as a light switch or similar. Okay, cool. So what we need to do though is set up something else with that. We simply use red LED.toggle, close bracket, open bracket, open bracket, close bracket, of course it's that way around, instead of the usual line turning the LED on and off. Easy, try the code below and see what happens. So now we're going to end up making, I'm assuming, the green button, or the red button or something, a toggle switch. So we'll get rid of all this code. I'll copy this. There, press play. Now which button is going to do it? Is it the red one? No, it's the green one. Oh dear. Oh no, it's the red one. Again, because there's no initialization of the code in the first place, it doesn't know what state to be in. They really should have that in their code. It's very important when you have code that whatever state you expect at the very beginning of you running your code, you set everything to what you expect it to be. They're not doing this in these examples, and they really should, because a moment there I thought it wasn't working, and it was. So anyway, the red button is a toggle switch now. Well, maybe it is toggling and stuff, I don't know, maybe the button didn't stuff, but it is very important to have things set. Yeah, you see, it's setting for the fact of if it's equal to 1. So yeah, basically we toggled it, and it assumed we were already toggling it to that, and it should be initialized. Anyway, activity number 5, counting the buttons. Oh, we can make our program count and manipulate numbers using the buttons to add or subtract from a stored value. This comes in handy when creating little games, or setting things like volume, brightness, and other things that we range the values. The stored value is called a variable. Okay. As explained yesterday, variables are a certain way of holding data into things. It's if you've done algebra at school, you'll understand what that means from the get-go. But basically, it's coming up with a letter or even a word, and then well, basically directing a value to that to represent it. No other way of explaining it really. That's exactly what a variable is. It's so that you can have something that you remember what that value is, and then you can put a value into that variable. Maybe I didn't explain that so well, but basically that's what it is. It's just makes, instead of trying to keep numbers all in your head floating around, it's easy just to keep sending it one direction, and then you can go back and check on what that value actually is within that variable. And at the moment we're starting off with integers, but they can also be floating points, a float, a word, a string of text. I'll not confuse matters what all that means at the moment, but basically an integer is a whole number. A floating point is like 12.9. It needs a decimal point in it. And a string, a word or a string or something like that of text is literally that. So you could actually have a variable called box, and then you could say the variable was spectrum, and so that there's a spectrum inside the box, sort of thing. But you would always know where the box is, but you might not know what's inside. And that's the thing, is that you can change the value inside and then come back and find out what it is later on. The red button will reduce the count by 1. Basically, the code is going to the code below first imports the things we need, sets our pin number up, then creates a variable called count, which we'll use to track presses on our buttons as part of the while loop. The red button will reduce the count by 1. The green button will increase it by 1. Feel free to swap them around if you prefer. You have the skills to do that now. So yeah, you can change the code about now. So let's get rid of all this old code. Cut and paste this code. Put that in. Run it. So now, what did it say? It was green added 1, red took it away. So we press green a few times. You see a little counter going up to 10, and we can press the red one to bring it back down again. So, yay. And by all means, read this and what it's doing and stuff so you can learn and what all this code actually means. Right, counting with buttons, the blinky version. We're going to make our LED flash each time one of the buttons are pressed, just for a bit of visual feedback and a way to show you yet another way to utilize LEDs in your projects. So basically it's, what's it doing? Yeah, basically it's just going to flash it for 0.2 of a second. So again, let's get rid of all this code. And again, you should really sit and learn what all's happening. Press play. Right, so we should be able to press green. So every time we press a button now, I'll press the red one to make it come back down again. So the green's counting down, but either way though, it's checking to see, has a button been pressed, and if the button has been pressed, which one was it, so that we know if we should add a 1 or take away 1 from the count. So that's working nicely. Activity number 6, and that's day 3 complete. So there we go. It talks about everything that we've done there. So that was, it looks simple enough, but please have a look at the code and try to learn from the code of what's actually happening, because that's the whole point of this, is that you start to try to find out, are you interested in programming? Are you interested in making your own little circuits do things? They're not going to be overly complicated at the moment, but that you don't want to start with overly complicated. You always start off with the basics and slowly but surely learn. And that's why people who do know an awful lot shouldn't take the mickey or make fun of people that are learning from the low end of things, because that's where they started. They might have been 9 or 12 when they first started, and they've got 30 odd years now. But who cares? You can be in your 40s and still learn from the basics. Right. As always, have a look at the description down below. Check out the links for the Patreon and for my Discord. Don't forget to hit that like button, the subscribe button, and that notification bell so you know to come back tomorrow. But as always, have